Hello, I'm Nick Williams.
And I'm Logan Voigt.
And we're here to present our senior project, Shot Silencer. Shot Silencer is a project that we created to noise cancel the sound of a gunshot. Since we're on campus and guns aren't allowed, we are going to simulate a gunshot and noise cancel it. To simulate a gunshot, we first play the sound of a gunshot through this speaker. We pick that up on our microphone. We do some inverting to the signal and gain the signal back up to play through this speaker. This speaker plays the inverted sound, which we pick up on this microphone. This microphone also picks up the original sound from the first speaker. Logan Voigt will explain a little more in detail of how our system works.
So we start with our audio recording on this computer, and through this cable we get that signal into our circuitry. The first thing that we have is this amplifier. This will gain the signal enough to power our speaker, and so we go over to our first speaker, and now that the signal is strong enough, the speaker can produce the sound. That sound is captured by this microphone, which goes into our next op amp. The output of the microphone is about 1.5 millivolts, which is below the noise floor of our circuit. So this amplifier gains that signal up out of the noise. Then these capacitors will remove the DC offset that this amplifier produces. So our signal is back at DC. And then we go into this amplifier, which is our inverting amplifier. This both inverts the signal and produces some gain to get our levels where they need to be. The output of this amplifier is tied to a low-pass filter, which removes some of the noise that has been created by our amps so far. After that, we go into another one of these op amps, which powers the next speaker. So it gains the signal up high enough that the speaker can respond. And then, like Nick said, both the inverted signal and the original signal are captured on this microphone, which is recorded in Audacity on this laptop over here.
In order to noise cancel the sound of a gunshot, the audio that comes out of this speaker needs to arrive at this location the same time that the inverted sound comes out of this speaker. In order to deal with the timing of this, we've incorporated a measuring tape along the bottom of these, and we can slide the microphone and speakers back and forth so that they're at appropriate distances. With more time, we would also develop a circuit to handle the timing delay. Now we will demonstrate our shot silencer. Logan will record the audio signal that is transmitted through this inverting op amp, both the input and output, so that we can show that it is indeed being inverted. First, we will just hit play on this sound effect, and we will listen to both speakers. Let's see how the inverting did.
So as you can tell, these smaller signals, which are the louder, lighter clicks that we heard in the audio of the gun reloading. This first one before the inverting had a spike going up, and this one has a bigger spike going down, and you see that trend for the next one too. Then remember, these next waveforms look slightly different because the gain is slightly different, but you can see there's a bigger peak on top up here and the bigger peak is down below. And we have maybe this jagged shape down here, which approximately matches that jagged shape down there. So this confirms that it is indeed inverting.
Thank you for watching our demonstration of shot silencer.